Good afternoon, everyone. Welcome to the session for MMPC 005. If you remember last time, in our last session, we were talking about probability. We had discussed some problems related to tossing of a coin, a dice, and a problem related to balls in a bag. In continuation with that, that was till unit 5. Today, actually, we have to start unit 6, but before starting that, I will just discuss about what to refresh you, what probability is, and what kind of conditions are there, and what are the basic things we have to keep in mind. Basically, probability is the occurrence of any event, what it will happen or it will not happen. That is basically we are not sure about it. As far as its representation is concerned, the probability is represented by small p. That is the probability of success. And the other part is probability of failure. And that is denoted by q. And we have to keep one thing in mind that probability of success and the summation with probability of failure will always be equal to 1. It will never be or it can't be less than 1 or more than 1. It will be 1 only. जैसे कि हम ये कहते प्लस ना होना बराबर है 1 के. I'm talking in Hindi because I will be using English and Hindi both in my sessions. Probability is favorable cases of the event divided by total number of cases. Suppose we have a coin has either a head or a tail. That means two things can happen. And what is the probability of getting a head on a flip of a coin? That is, your success favorable case will be 1 and total number of cases will be 2. If we ask about probability of getting a head, it will be 1 by 2, and probability of tail will be 1 by 2. When you will be adding it, that means 1 by 2 plus 1 by 2 is equal to 1. Here now, if we talk about unit 6, is the slide visible to you? क्या आप लोग स्लाइड देख सकते हैं?
Yes, sir.
Yes, sir.
Okay. Now that is unit 6. We will be talking about discrete probability distribution. Here, what we have to do, we have to consider all the events starting from 0, that is for the failure, 1, 2, 3, 4 till n. Now, if all the possible outcomes of the experiment together with their chance of occurrence were made available. This is what we are going to do in discrete probability distribution. If betting on head, find that a toss of 3 coins, that means total number of cases will be 2 raised to the power 3. That is 2 into 2 into 2. 2 to the 4, 4 to the 8. That means total number of cases will be 8. When you are tossing three coins and you are talking about head, so either no head will be there, one head will be there, two head will be there, or three heads will be there. That means for two heads it will be 3/8, and for three heads it will be 1/8. How this came. This representation of all possible outcomes and their probability is known as probability distribution. You need to apply a discrete probability distribution. We'll discuss what this discrete probability distribution is. And discrete probability distribution can be used in decision making. Initially, in my first session, I said, what is the purpose? हम मैथमेटिक्स का कंपोनेंट ये पेपर क्यों पढ़ रहे हैं, कहाँ इसकी ज़रूरत होगी. तो हियर इज द फर्स्ट केस जहाँ हमें कोई डिसीजन लेना होगा, बिकॉज डिसीजन इज ऑलवेज मेड अंडर probability. Outcome of toss of three coins were expressed in the terms of number of heads. H can assume values of no head, one head, two head, three head. That's it. That means you will see just was say one thing. We toss three coins, and our possible outcomes are four. Remember that thing. Whatever the condition is, whatever the tossing is, you will always get plus one answer. That means plus one cases will be there. I will see to show you how this happens. This uncertain real variable h, which assumes different value depending on the outcomes of an experiment, and to each of whose value a probability assignment can be made, is known as random variable. A discrete probability distribution counts occurrences that have countable or finite outcomes. This is in contrast to a continuous distribution where outcomes can fall anywhere on the quantum. Common example of discrete probability distributions include binomial, Poisson, and Bernoulli's distribution. We will be discussing about these three right now. A discrete probability distribution is between 0 and 1 inclusive. The sum of the probabilities is 1. Remember, these are the properties. Each probability is between 0 and 1. That is the basic of probability. Second one is the sum of probabilities will be 1. If you are not getting 1, that is you have committed some mistake, आपने कोई गलती की है respective probability निकालने में. Discrete events are those with a finite number of outcomes. That is tossing a dice, coins. For example, when we flip a coin, there are only two possible outcomes, head or tail. When we roll a six-headed die, we have only obtained one of the six possible outcomes. One, five, six. Now, we have to remember a formula that is the mean formula. Mu is equal to summation x times probability of x. The variance sigma square and standard deviation sigma of discrete random variable x are numbers that indicate the variability of x over numerous trials of the experiment. See over here, discrete values when we are talking about head tossing of a coin. No head, that means zero head. Probability will be 0.125. When we have one head, the probability will be 0.375. We have two heads, probability will be 0.375. And if we have three heads, then the probability will be 0.125. I request everyone to tell me the sum of these numbers. What is the sum of these numbers? Any one of you, sum of these numbers. I'm audible to
Yes,
you.
sir, it is equal to 1.
That is what I'm asking. This is what I told you. His summation of all the probabilities will be 1. That means the calculation is correct. Now you can see when we are getting the values of 0, 1, 2, 3, that is your discrete values. Random variable is head, and the probability distribution is the whole chart. Now, how to calculate it? Probability distribution of a random variable. A description giving the value of a random variable along with the corresponding probabilities is called probability distribution of the random variable. If a random variable x takes the value x1, x2, x3 till xn, and the respective probability will be p1, p2, p3 till pn, then the probability distribution of x is given by this. That means your random variable is x. It is written over here, x1, x2, x. This event will be written here, x2 here, x3 probability here, and last xn here. When you will add these numbers, it will be equal to 1. Now, the above probability distribution of x is defined only when each p1, p2, p3, p4 is either equal to 0 or greater than 0. Is the slide visible to you now?
Yes, sir.
Okay. Now going back, the above probability distribution of x is defined only when p1 is greater than or equal to 0. That means the value of p1 will be 0, 1, 2, 3, 4, greater than 0. And summation of probabilities, that means summation of P1, P2, P3, P4 till Pn will be equal to 1. This is what you have to remember. Because if anything, if you have committed any mistake in calculating the probability, the summation of all the probabilities will not be equal to 1. You have to remember that thing. Mean is equal to summation of I equal to 1 till n. It is the product of xi and pi. Variance, it is denoted by sigma square, which is equal to summation of the square of x into pi minus mu square. Mu square is mean, mean square. And standard deviation is under root of variance. Variance is defined as the expected value of the square of the difference between the random variables and its expected value. Now here we see now. This is what I told you at the beginning of the session, that during the later half we will see how it came. Now here the question is, you have to calculate mean, variance and standard deviation of number of heads when three coins are tossed. Sample space, all the eight conditions are written in front of you. That is, when you are flipping a coin, three coins come down on the ground, you will get three tails: two tail and head, tail, head, tail, head, tail, 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 head, 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 tail, head, tail, and three heads. As I told you, sample size will be 8. Here you can see the 8 cases. Now, what is X? It is the number of heads in a tossing of 3 coins. The number may lead of heads is possible. You can see no head, one head, two head, or three heads. Total number of cases will be 3 plus 1, 4. Now we will find out the probability of no head. If you have no head, there is only one condition of no head. That is tail on all the three coins. That is 1 by 8. Its probability will be 1 by 8. If you have one head, go back to the sample space, you will see that it is HTT, THT, and HTT. That means there are three cases out of 8 where we are getting one head. If we are getting two heads, again it is 3. That means its probability will be 3 by 8. And for x is equal to 3, that means all the three heads. That will be 1 by 8. Now, writing this in terms of a tabular form. That means your x value is 0, 1, 2, 3. And their respective probability is 1 by 8, 3 by 8, 3 by 8, and 1 by 8. Please add these numbers and see what it comes out to be. What is the summation of 1 by 8, 3 by 8, 3 by 8, and 1 by 8? What will you get? That means our calculation is correct. Okay. Now moving further, we have to calculate mean. Means formula is, it is denoted by mu. It is the summation of product of xipi. So what we will do? We will multiply these two numbers plus product of these numbers plus product of these numbers and plus product of these numbers. This is written over here. This comes out to be 3 by 2. That means you have to use formula sigma square equal to summation of x square pi minus mu square. Your x square will be 0, square will be 0 into 1 by 8 plus 1 square will be 1, 1 into 3 by 8 plus 2 square will be 4, 4 into 3 by 8 plus 3 square will be 9, 9 into 1 by 8 minus mu square. Mu is 3 by 2. That will be 9 by 4. When you will be evaluating this will be 0, this will be 3 by 8, 12 by 8 plus 9 by 8. So this comes out to be 3, 2, 12, 3, 12, 15, 15 plus 9 is 23 divided by 8 minus this. When you will be evaluating, you will be getting 3 by 4. You have to calculate standard deviation of also, so it will be under root of 3 by 2. 3 by 2 under root will be root 3 by 2. Root three's value is 1.732 divided by 2, it will come approximately 0.87. This is how, under probability distribution, mean, variance, and standard deviation is calculated. Formulas are not going to change at all. Now comes Bernoulli's theorem. Let there be an independent trial in an experiment, and let the random variable x denote the number of successes in these trials. Let the probability of getting a success in a single trial be p, and that of a failure be q. This has been told to you, and summation of p plus q will be equal to 1. Then, if that is the condition, you have to calculate the probability of an event, and you have to apply this formula NCR into p raised to the power r into q raised to the power n minus r. NCR is related to combination, and this is opened up. NCR, you can see it is written over there. NCR is equal to n factorial upon r factorial into n minus r factorial. Now question arises, how to open this factorial? Your 0 factorial is 1. Remember that thing. 0 factorial is 1. 1 factorial is 1. 2 factorial is 2. 3 factorial is 6. Now question arises how these numbers come. If you have n factorial, when we open up this n factorial, this comes out to be n into n minus 1 into n minus 2 into n minus 3 till 1. That means initial three terms will be n into n minus 1 into n minus 2, and the last end of this series will be 3 into 2 into 1. Now see how this is a line distribution. If you have x is equal to 0, 1, 2, 3 till r, and your px will be q raised to the power n, for 2, it will be n c2 p raised to the power 2 q raised to the power n minus 2. And for the last one, it will be ncr p raised to the power r q raised to the power n minus r. This is known as binomial distribution. A typical example of binomial distribution process are coin tossing and success failure situations. What is the condition now? How will you come to know what are the conditions which have to be kept in mind at the time of applying binomial theory? The experiment is performed with fixed number of trials and performed for finite trials. Each trial must give either a success or a failure. And the third one is probability of a success in each trial is same. Under that condition, your mean will be denoted by mu is equal to n into p. That means the product of number of trials into probability of success. Your variance will be sigma square is equal to npq. And your standard deviation, that will be under root of variance will be under root of npq. Then comes your next one is Poisson distribution. Poisson distribution is applicable to events occurring randomly over time and space. Where are the conditions? What are the conditions where we can say that we can apply Poisson distribution? Number one, to count the number of defects of a finished product. Number two, to count the number of deaths in a country by any disease or natural calamity, to count the number of infected plants in the field, or to count the number of bacteria in the organism, or the radioactive decay in atoms. Or another example is to calculate the waiting time between the events. Now, these are the conditions where normally we apply Poisson distribution. Now, question arises: what is how we will calculate the probability of an event in Poisson distribution? Poisson process called now Poisson with a very large number of trials. Number of trials will be maybe in hundreds, and with to product of n into p, and r is the number of success. When we are finding out the probability of success, its formula will be e raised to the power minus m into m raised to the power r upon r factorial. Now, as far as the value of e raised to the power minus m is concerned, it will be provided to you in your question. If the problem has to solve by Poisson distribution, the value of e raised to the power minus m will be, the formula is for Poisson distribution e raised to the power minus m into m raised to the power r upon r factorial. Now, what are the properties of Poisson distribution? The events are independent. The average number of successes in the given period of the time alone can occur. No two events can occur at the same time. A constant. The standard deviation is always equal to square root of the mean because of the variance. Now the problem comes: how to identify what are the things which have to be seen in a problem. If 3% of electronic units manufactured by a company are defective, that means probabilities of defective units. Find the probability that in a sample of 200 units, see, sampling of 200 units, then less than two bulbs are defective. Now, the thing is that, first of all, we have to calculate the probability of defective units. Probability of defective units is 3%. 3% means 3 by 100. That means your P will be equal to 3 by 100, which is equal to 0.03. One thing has been utilized. Now, second is out of a sample of 200. That means n is equal to 200. Now see, n is too large and your probability is too small as compared to 200. Correct? That means you have to use Poisson distribution. We have to calculate lambda. That is the mean. Lambda is equal to sum of n into p. Your n is 200 and your p is 0.03, which comes out to be 6. That means your lambda is 6. This is a Poisson distribution. So we have to apply the formula of e raised to the power minus lambda into lambda power r upon r factorial. Or here we have taken x. Now the last part of the problem. We have to find the probability that in a sample of 200 units, less than 2 will start defective is 0.017229. This is the exact method by which this problem will be solved. Poisson distribution. There are frequent interruptions due to the server problem. Now going back to the problem, find the probability that in a sample of 200 units, less than 2 bulbs are defective. That means you have to calculate the probability of x less than 2. Less than 2 means no defective or value of x by 0. And for one defective, you have to replace the value of x by 1. Formula is e raised to the power minus lambda times lambda raised to the power x upon x factorial. For the x is equal to 0, will be e raised to the power minus 6 into 6 raised to the power 0 divided by 0 factorial plus e raised to the power minus 6 into 6 raised to the power 1 upon 1 factorial. Now, anything raised to the power 0 is 1. Anything raised to the power 0 is 1. And your 0 factorial is 1. That means first part will be only e raised to the power minus 6. And the second part, 6 raised to the power 1 will be 6. And 1 factorial is 1. 6 divided by 1 is 6. That means it will be 6 times of e raised to the power minus 6. Take e raised to the power minus 6 common. It will be 1 plus 6. That means 7. Value of e raised to the power minus 6 is 0.00247 into 7. Multiply it, you will get 0.01729. That means the probability in a sample of 200 units less than 2 bulbs are defective is 0.01729. This is the exact method by which this problem will be solved. And this problem is of Poisson distribution. Poisson distribution, why? Probability is too short and the sample size is too large. Now if the screen is visible to you, moving ahead, that is now
Yes, sir,
probability
it's
and
visible.
distribution. Okay. We will be talking about unit 7, that is continuous probability distribution and decision theory. Now, what will happen over here now? Here, the variable of interest may take any value within a given range. This type of random variable, which can take an infinite number of values, is called a continuous random variable. And probability distribution of such a variable is called continuous probability distribution. Now, the basic part starts because this part will be used here in other units also, as well as in your MMPC 15, that is your research methodology. This is normal distribution. Normal distribution is the most versatile of all the continuous probability distribution. It is found to be useful in statistical inferences, characterizing uncertainties, mean life processes, and approximating other probability distribution. What is a normal distribution in statistics? A normal distribution is a continuous probability distribution that is symmetrical about mean. Most of the observations clusters around the central peak, and the probabilities of values further away from the mean taper off equally in both directions. What are the properties? This is the basic PDF of the normal distribution is given by fx equal to 1 upon sigma under root 2 pi into e raised to the power minus 1 by 2 x minus mu whole square. Remember this thing, x minus mu upon sigma. We will be using this part only in our mathematical calculation. Now question arises, what are the real world problems where we are going to use normal distribution? That is birth weight of babies, height of males, blood pressure, etc. We'll see how it is applied. And what are the properties of normal distribution? Some of the properties of normal distribution are: in normal distribution, mean, mode, and median are all equal. The total area under the curve should be equal to 1. The normal distributed curve should be symmetric at the center, and there should be exactly half of the values on the right side of the center and exactly half of the values on the left hand side. That means probability of the left side will be zero point 0.5 and the probability of right side will be zero point 0.5. When you will be adding them up, you will be getting 1. Now we talk about the area under the normal curve. We plot fx versus x, which gives us the normal curve, and the area under the curve gives the probability. Correct? The normal distribution is symmetric about mean, and the area of each side of the mean is zero point 0.5. Zero point 0.5 on the left and zero point 0.5 on the right. The empirical rule states that 99.7% of the data observed following a normal distribution lies within 3 standard deviation of the mean. Under this rule, 68% of the data falls within 1 standard deviation, 95% within 2 standard deviation, and 99.7 within 3 standard deviation of the mean. Now, the formula for calculating Z score. Z is equal to x minus mu upon sigma. This is the same number what I told you to remember, where x is the raw score, mu is the population mean, and your sigma is the standard deviation. Everything will be given to you in the problem. As the formula shows, Z score is simply the raw score minus population mean divided by population standard deviation. That means your z is equal to x minus mu upon sigma. That is x minus mean upon standard deviation. Now see, normal. How does the normal graphs look like? Normal distribution describes continuous data which have a symmetrical distribution with a characteristic bell shape. Binomial distribution describes the distribution of binary data from a finite sample. Now we will calculate probability. A radar unit is used to measure speeds of car on a motorway. The speeds are normally distributed. First case is confirmed that this problem is related to normal distribution with a mean of 90 kilometers per hour. If it is a problem of normal distribution, you have to have mean and standard deviation. Your mean is given in the problem 90 kilometers per hour and the standard deviation is 10 kilometers per hour. What is the probability that a car picked at random is traveling at more than 100 kilometers per hour? We have to calculate the probability. Now, this is a case of normal distribution. For normal distribution, you have to calculate Z, and for calculating Z, you should have X, you should have mean, and you should have standard deviation. X is that random variable at which the probability has to be found out. That is 100 in this case. Your mean is 90, which is given in the problem, and your standard deviation is 10. That means 100 minus 90 divided by 10 will be 1. Now, see the steps how it is written. The question was probability that the a car which is picked at random is running at 100 more than 100 kilometers per hour of the speed. That means x will be greater than 90. X has been replaced by z. So z will be equal to z will be greater than 1. Now we know that the total area in the graph is 1 and the value what we will get from the table of z equal to 1 will be on the left side. So that means total minus left side will be the probability of the problem. Your total area is 1 and the probability of the on left of the z is 0.8413, which is equal to, when subtracting this from 1, you will get 0.1587. Now your question arises, from where we get this 0.8413? We have normal standard curve graph table. The value will be given to you in the problem. You have to apply it with your concept of solving the problem. Don't write 0.8413 as the answer. Your complete answer will be total area minus area to the left of z equal to 1. And the value of z equal to 1 will be given to you in the problem. What are the characteristics of standard normal distribution? Now here, some clues for solving the problem is being discussed. The Z score of a standard normal distribution is a standard score that indicates how many standard deviations are away from the mean and individual values of x lies. Now, when Z is positive, the value of x is greater than mean. When Z is negative, the value is less than mean. And if Z is equal to 0, in that case, X value is equal to Z score tells us how many standard deviations are away from the mean each value lies. This is the actual graph representation of normal distribution. See to this graph very carefully. At the center, you will see 0. On the right side, you will see 1. Then away from it, 2 till end. And on the left hand side, you will see -1, -2, and so on. What I was telling you that this is the center value. The area under this curve, this part, will be 0.5, and the area under this part will be 0.5. When you will be adding these two, you will get 1. Now keep one thing in mind. This blue line never touches this bottom line. Never. Now, world example problems usually happenings in the real world follows normal distribution. This enables researchers to practice normal distribution as a model for evaluating probabilities linked with real world scenario. Basically, the analysis includes two steps. What we are doing? Converting raw data into the form of Z score. We have done it already in the last problem. Using the conversion equation given as Z is equal to X minus mu upon sigma. And secondly, finding the probability. After the raw data is transformed into Z scores, then with the help of straight normal distribution table or normal distribution calculators available online to find the probabilities linked with the Z score. This is what we are talking about here, and this is what we did over here. The problem is almost the problem is related to a normal world scenario. This is normally studied by police of the respective place to see how many vehicles are running at speed of 100 kilometers per hour at a particular moment of time randomly, because the radar is picking up all the movements of the car. Finding the probability after the raw data is transformed into Z square, then with the help of standard normal distribution tables or normal distribution calculators, we can find out the probabilities which are linked with Z score. Now see to the problem. We will come to the problem simultaneously. This is the problem. For some computers, the time period between charges of the battery is normally distributed with a mean of 50 hours and a standard deviation of 15 hours. I told you this is a case of normal distribution because in the problem it is straight away written as normally distributed. Secondly, for normally distributed, you need mean and standard deviation. Both things are given to you. Now, moving further. Achal has one of these computers and needs to know the probability that the time period will be between 50 and 70 hours. Now, this is how to apply normal distribution into this problem. This is a problem of normal distribution. Confirm. You have mean with you and you have standard deviation with you. Now, the second part is how to find out what are the values of x. Here, x is the random variable. Random variable is that for which the probability is to be asked. Or yeah, is being asked. Your probability is for x is equal to 50 and x is equal to 70. That means you will be calculating two z values. Z at x is equal to 50 and the z between x z equal to 70. You will be getting two values of z. Here you got the two values of z. Now see, Mu is given to you, standard deviation is given to you. You have to find the probability that between 50 and 70. So mathematically it will be written as probability 50 less than x less than 70. This is the actual terminology what has to be written for solving the problem. Now our problem is to convert these values of x to z. That means we have to apply the formula z is equal to x minus mu divided by sigma. When x is equal to 50, your z is 0, correct? When x is 70, your z is 1.33. Convert that thing from the convert the problem of z into a problem of x into z. Now that will be probability 0 less than z less than 1.33. Now see to the representation of the problem. This is a normal distribution, so randomly you will draw this. Draw the center line over here, and you have two values of z equal to 1, z is equal to 0 and z is equal to 1.33. Allocate it over here randomly because these both the values are positive, so it will be on the positive side. Now this shaded area has to be evaluated. Yeah, that means your answer will lie over here. Now what to do? This is the area left to 1.33 minus area of z point, z is equal to 0. These two values, for z is equal to 0, it is zero point 0.5, and for z is equal to 0. Z is equal to 1.33, its value is this. That means you will be subtracting zero point 0.5 from this. 0.9082 minus zero point 0.5, which comes out to be 0.4082. That means this is your answer. Probability that Achal's computer has a time period between 50 and 70 hours is 0.4082. And if same question, everything is being asked by the percentage. What is the percentage? That the Achal's computer battery will lie between 50 and 70. You have to evaluate same thing, but in the last line, you have to multiply it by 100. That means it comes out to be approximately 40%, 41%, because your answer will be 40.82. From where you found out 0.082? Huh? That will be given to you. That is the value of z point 1. Z is equal to 1.33. That will be given to you. You have to remember that z is equal to, for z is equal to 0, it is zero point 0.5. Okay, another problem. Because this is, I'm discussing this part with two, three problems because this is the actual problem from where normal distribution is applied. One should be aware of how it is applied. Most graduate schools of business require applicants for admission to take the Graduate Management Admission Council's GMAT examination. Scores on the GMAT are roughly normally distributed, with mean of 527 and standard deviation of 1.112. Now, in the problem itself, it is written that it is of normal distribution. For normal distribution, you need mean given, you need standard deviation given. Now what? What is the probability of an individual scoring above 100? That means above 500, what is the probability? Okay, we know mu, we know sigma. First of all, calculate z equal to z at 500. So it will be 500 minus 527 divided by 112. If you remember here, the way random variables value is less than mean. That means it will come on the left side of the graph. Okay, its value is z's value at 500 is negative 0.082. 24107. Draw this, plot this normal, and write this is 0. You get 0 is this z is equal to minus 0.247. Write it at left hand side, and you have to find out scoring above 500. Above 500 means the area of this part. Area in this part is totally 100. 1 minus this part. At this negative 0.24, the value is 0.4052. It will be given to you in the problem. You have to subtract it, this value, from 1. That means you will be getting this multiplied by 100. It will be almost 59%. Another problem, the average number of acres burned by forest and range fires in a large New Mexico county is 4,300 acres per year, with a standard deviation of 75 acres. Okay? The distribution of the number of the acres burned is normal. This is a problem given to you. You need standard deviation that is given to you. The next step is to find out the probability that between 2,500 and 4,200 acres will be burned in any given year. That means you have mu, you have sigma, and the values for x are 2500 and 4200. Calculate the value of z. You can see the calculation over there. For z is equal to 2500, it is negative 2.4, and for z equal to 4200, it is negative 0.13. आप ये प्लॉट करिए एज रफ बाय हैंड, सेंटर लाइन पे 0, दो वैल्यूज हैं आपकी, दो वैल्यूज के बीच का पार्ट आपको निकालना है. ओके, व्हाट विल यू डू? टेक्निकली हमें जब ग्राफ मिलता है Okay, so your problem was probability of 2500 less than x less than 4200. You have calculated the values of z, so it will be probability negative 2.40 less than z less than negative 0.13. That means we have to remove these signs and find out the actual answers. For that, you have to calculate Pz less than minus 0.13 minus probability z less than minus 2.40. The values at for 2.40 and for 0.13 will be given to you. Subtract these values. Probability, remember one thing, probability will never be negative or less than or greater than 1. That means the area will be 0.4483 minus 0.0082, which comes out to be 0.4401. Values for both z equal to 1, z equal to 0.13 and z equal to 2.40 will be given to you in the problem. Now, what we have understood, exponential distribution is found to be useful for characterizing uncertainty in machine's life, length of telephone call, etc. Normal distribution is found to be useful for characterizing dimensions of machine parts, height, weights, etc. Now comes your decision theory. I told you that this probability distribution is used in decision making process. We will see how. A little bit of it will be there. A necessary condition for the existence of a decision problem is the presence of alternative ways of action. When in our life also we come across so many things. So what we find, what we want to do, we want to find the other alternative, what how it can be performed. That means either the other way or the shortest route by which the problem can be sorted out. Each action leads to a consequences through a possible set of outcomes. The information on which might be known or unknown. One of the several ways of classifying decision problems has been based on this knowledge about the information on outcomes. Decision making under certainty. The information and outcomes are deterministic and are known with certainty, and decision making under uncertainty. That is decision theory. That means what happens over here? The information on outcomes are probabilistic. We are not sure about it. No data is given to us or no data is available to be analyzed. So that we from our guess work we find out the probability with the probabilities known or unknown. Depending on the planning horizon under consideration, as also the nature of the decision, we have either a single state decision problem or a sequential decision problem. Marginal analysis and DT approach. Marginal analysis for solving such single stage problem. For sequential decision problem, the decision tree approach will be used. In both the marginal analysis and the decision tree approach, we will be using the expected profit as the criteria for our discussion. Whatever you are going to do, if you are going to invest anything, so first of all, the question arises our in the mind that what will be the profit. Now we are starting a startup thing. So how we can calculate it? Its break-even point, and what will be the profits, and how we will, and by what time we will be in a position to make the profits. So that means it has to be in terms of monetary value. First of all, we will start from expected monetary value, that is EMP. This does not take into account the decision maker's attitude towards risk. Preference theory. This provides us with the remedy in the context of enabling us to incorporate risk in the same setup. The other problem with expected monetary value is that it can be applied only when the probabilities of outcome are known. Probabilistic में तो हम कर सकते हैं, नॉन probabilistic में नहीं करेंगे. For problems where the probabilistics are unknown, one way out to assign equal probabilities to the outcome and then use EMB for decision making. However, this is not always rational, and we will find other criteria that are available for deciding on such situations. And ties together much of economic thought. In any situation, people want to maximize net profit. How that can be done? That means total benefits minus total cost. Under that condition, you will be getting net benefits. But what is the control value? Control value is nothing but variable. To do marginal analysis, we can change Now, what are the key procedures for using marginal analysis? Identify the control variable that is denoted by CV. Determine what the increase in total benefits would be if one more unit of the control variables are added. This is the marginal benefit of the added unit. Determine what the increase in total cost would be if one more unit of the control variables are added. This is the marginal cost of the added unit. And if the unit's marginal benefit exceeds or equals its marginal cost, it will be added. Remember, you look only at the chance changes in total benefits and total costs. If a particular cost or benefit does not change, ignore it. That means you don't have to consider that part. Why does this work? Because marginal benefit is equal to increase in total benefits per unit of control variable. Mathematically, they are denoted by delta TR divided by delta QM, which is equal to marginal revenue. Marginal cost, increase in total cost per unit of the control variable. That will be delta TC upon delta MC, which is equal to MC. So, change in net benefits. Marginal benefit is change in net benefits is the difference of marginal benefits and marginal cost. Why does this work? When marginal benefits exceed marginal cost, net benefits goes up. So the marginal unit of the control variable should be added. Now, how to formulate the problem? A decision problem is characterized by decision alternatives, states of nature, and resulting payoffs. The decision alternatives are the different possible strategies the decision maker makes or when he applies. The state of nature refers to future events not under the control of the decision maker, which may occur. States of matter should be defined so that they are eventually exclusive and collectively exhaustive. Then comes your influence diagram. An influence diagram is a graphical device showing the relationship among the decisions, the chance events, and the consequence. Squares or rectangles depict decision nodes. Circles or ovals depict chance nodes. Diamonds depicts consequences nodes. And lines or arcs connecting the nodes show the direction of influence. Now, what is meant by decision tree? Decision tree is a chronological representation of the decision problem. Each decision tree has two types of nodes. Round nodes, which corresponds to the state of nature, and square nodes corresponds to the direction alternatives. Yeah, decision alternatives. The branches leaving each road round node represents the different states of nature, while the branches leaving each square node represents the different decision alternatives. At the end of each limb of the tree are the payoffs attained from the series of branches making up that limb. What happens when decision making is without probabilities? Three commonly used criteria for decision making when probability information regarding the likelihood of the states of nature is unavailable. First one is optimistic approach. Second one is conservative approach. And the third one is minimum regret approach. Now, what happens in optimistic approach? The optimistic approach would be used by an optimist decision maker. The decision with the largest possible payoff is chosen. And if the payoff table was in terms of cost, the decision with the lowest cost would be chosen. We always use that thing. Conservative approach. The conservative approach could be used by a conservative decision maker. For each decision in minimum payoff is listed and the decision corresponding to the maximum of these minimum payoffs is selected. Hence, the minimum possible payoff is maximized. Now we move to the most important part, that is sampling and sampling distribution. Here, what we will be doing, we will be studying about sampling methods, sampling distributions, testing of hypothesis, and chi-square test. I don't know how many of you remember what is meant by sampling. What is sample is? We will start it with the introduction. When one is interested in measuring some attributes of a large or infinite group of elements by studying only a part of it. This process of interfering something about a large group of elements by studying only a part of it is referred to as sampling. For example, we will consider a case. Bank of India, we have to find or we want to measure the level of employees' motivation. This is our purpose. Now we will be administering a questionnaire of 250 employees from different branches and offices all over the country out of its 30,000 employees. That means from a gamut of 30,000 employees, we are randomly selecting 250 employees. That means our sample size is 250 and our universal size is 30,000 or the population size is 30,000. Now, what are the different definitions we will be using or terminology? First one is population. It is the collection of all the elements about which some inference is to be made as the population. Second one, any characteristics of a population will be referred to as a parameter of the population. Third one is some population parameters is inferred by studying only a part of the population, that is sample, and any characteristics of a sample is known as statistic. Now see to the problem. We have a rectangle and an ellipse. Now the thing is that what this rectangle filled with yellow color means the total gamut of 30,000 employees. Yellow part is the parameter which the motivation of the employees, what we are trying to study. Your statistics is what? It is the motivation level of the sample. What is this blue? Blue is your sample size of 2,500 employees. Blue part out of 30,000 you have taken 250 employees and Celsius or complete enumeration of the population. This is how we pick up the things or we are going to study. Now, what are the different terminologies what we are going to use? Because if we earlier we were talking about population, now we will be talking about sample. That means see very carefully what are the differences. In population, we call it as a parameter, but in sample study, we call it as a statistic. Your population size is denoted by n. Here, your population size is denoted by small n. Your population mean is mu, but here it is x bar. Population SD is given by sigma, but in sample SD, it is given by S. And population proportion is capital by capital P, but here it is given by small p. But this is the basic difference between the different symbols what we will be using. Now, question arises: what is the need for sampling? Here, the time taken for the study, cost involved in the study, physical impossibilities of complete enumeration, practical infeasibility of complete enumeration, and enough reliability and inferences based on sampling, and the quality of data collected. So these are the things on which the need of sampling starts. What are the different types of sampling? There are two basic types of sampling depending on who or what is allowed to govern the selection of the sample. First one is probability sampling. Here, each element in the population has same non-zero probability of getting included in the sample. And the second one is non-probability sampling. Here, a sample may be picked up based on the judgment or convenience of the enumerator. What are the different methods of probability sampling? First one is simple random sampling. Second one is systematic sampling. Third one is stratified sampling. And the fourth one is cluster sampling. As far as this simple random sampling is concerned, under this sampling, each element of the population has an equal probability of getting included in the sample. All other forms of probability sampling use this basic concept of simple random sampling, but applied to a part of the population at a time and not as the whole population. Probability in general, again, the same thing comes because we here we will be using permutation and combination. You are aware of the world of probability. Here, what is going to happen? We have to choose the sample size. That means from where, what will be the total of the sample size. Here, it will be calculated by NCN, where N is the size of different samples to be picked from a total population of N. Random sample sampling ensures that any of these samples has the same probability being picked up. That means 1 upon NCN. Systematic sampling. Systematic sampling proceeds by picking up one element after a fixed interval depending on the sampling ratio. For example, for a sample of size 10 from a population of size 100, our sampling ratio will be n by n, that is 10 by 100. That means 1 by 10, which means sampling has started. Then another sample would be members 7, 17, 27, 97. Yes, Mr. Hassan.
Dear sub, hope you are be fine and doing well. Thank you so much for your nice introduction. Just regarding the sampling, just I wanted to know that these are the kind of sampling which is we are using in monitoring and evaluation, or it's different.
We are talking about sampling in terms of mathematical part, and the concept remains the same. I'm just telling you how this sampling is done. When because we will be using mathematical tools. For that, you have to be aware of all the terminologies, what are the different types of samples are, and how they are used.
Thank you so much, dear sir, because I have worked in monitoring and evaluations. I have right now job as well as just we are doing such kind of sampling, random non-sampling, start first sampling as well as manicons. Just you're mentioning then just I wanted to confirm that is it the same or
Actually,
it will be different.
actually, what happens when we do it, we have a better preview of it. Now the thing is that I'm just telling what the theory is all about, and we are taking a random problems from the context to make you understand what this sampling is all about. What you are performing is same what I'm teaching over here. There is no difference because that times your data is in front of you and you are picking up as per your choice and as per the different criteria. So the theory will remain the same. Your application may change. Is that clear now? Now, from a sample of 100 numbers from 1 to 100, the sample size was of 10 and the population was 100. That means your sampling ratio will be 10 by 100, that is 1 by 10. That means you will be picking every 10 number from the given population. Suppose you started from 7. The first will be 7, then will be 17, then will be 27, and the last one will be 97. This is systematic sampling. Now we come to stratified sampling. The basic idea behind the stratified sampling is to divide the whole heterogeneous population into smaller groups of subpopulation such that the sampling units are homogeneous with respect to the characteristics under study with the subpopulation and heterogeneous with respect to the characteristics under study between or among subpopulation. Such subpopulations are termed as strata. Treat each subpopulation as a separate population and draw a sample by SRS from each stratum. Now we'll see how it is done. See, stratified random sampling is a method of sampling that involves dividing the population into smaller groups, what we call it as strata. The groups or strata are organized based on the shared characteristics or attributes of the member in the group. The process of classifying the population into groups is known as stratification. You can see over in this figure that whole population has been divided into three parts. Now see how this problem is. What exactly we want to say. Proportional stratified sampling. Suppose we have stratum number 1, 2, 3. Number of elements which are present are 200, 300, 500. Total is 1000. We have taken a sample size of 10, 15, and 25. That means your sampling ratio will be 1 by 20. In the second case, again 1 by 20. And the third case, again 1 by 20. This means this is a case of stratified sampling because all the three values are same and it is equal to 50 upon 1000, that is again 1 by 20. Now, disproportional stratified sampling. If the different strata in the population have unequal variances of the characteristics being measured, then the sample size allocation decision should consider the variance as well. It would be logical to have a smaller sample from the stratum when the variance is smaller than from another stratum where the variance is higher. We'll see how it happens. Now see what is happening over here. In the earlier problem, we didn't have variance. Now we have variance. If sigma 1 square, sigma 2 still are the variances of p strata respectively, then the statistical efficiency will be n1 upon n1 divided by sigma 1. Now see to the problem. 200, 300, 500 is the number of elements in the stratum. Your stratum variance is 2.25, 4, 0.25. Stratum standard deviation will be under root of variance. That will be under root of 2.25, which will come out to be 1.5. Under root of 4 will be 2. And under root of 0.25 will be zero point 0.5. Now we have to find out the sample size. That is 13, 26, 11. Find out the sampling ratio. You will see sampling ratio is different over here. Now comes your cluster sampling. Suppose we have a colony and it is divided into 11 blocks, naming from A to K. Cluster sampling is used in its situation by treating each block as a cluster. Two blocks are selected out of the 11 blocks at random, and then information is collected from all the families residing in those two blocks. Now, how will you compare cluster versus stratum? Strata are homogeneous within and different from other strata, but cluster should be heterogeneous within, and the different clusters should be similar to each other. A cluster is a mini population and has all the features of the population. The criteria used for stratification is a variable associated with the characteristics measured. Convenience of data collection is usually the basis of the cluster definitions. And there are very fewer strata, but there are many clusters. Multi stage and multi phase sampling. Multi stage sampling, where the sampling unit is something larger than an individual element of the population in all stages but the final. Multi-phase sampling is designed to make use of the information collected in one phase to develop a sampling design in a subsequent phase. A study with two phases is often called double sampling. Convenience sampling. In this type of non-probability sampling, the choice of the sample is left convenient completely to the convenience of the interviewer. Whatever the data may be, you may say, I will pick up the hundreds value, anything, but it's up to you or up to your choice for picking up the sample. The cost involved in picking up the sample is minimum, and the cost of data collection is also generally low. For example, the interviewer can go to some retail shops and interview some shoppers while studying the demand of non irritated beverages. You go to some, don't go to everyone. And from the sum, you may come draw a conclusion what will be the nature, what depending upon what your question is, how they will interpret, they will answer. Purposive sampling. In convenience sampling, any number of populations can be included in the sample without any restriction. When some restrictions are put on the possible inclusion of a number of sample, the sampling is called purposive. Reason. Then comes your judgment sampling. In judgment sampling, the judgment or opinion of some expert forms the basis for sample selection. The experts are person who are believed to have information on the population which can positions. Or even when the objective of the study is to collect a wide cross-sectional view from one extreme to the another. Quota sampling. Even when we are using non-probability sampling, we might want our sample to be representative of the population in some defined ways. This is sought to be achieved in quota sampling so that the bias introduced by sampling could be reduced. For example, family size could be another criteria, but when we set quotas for families with family size of up to 3, between 4 and 5, and above 5. However, if the number of such families is large, it becomes difficult to locate sample members satisfying the combination of the criteria. Now is the most important part, how to make or how to choose sample size or what is sample size is. One of the most important factor that affect the sample size is the extent of variability in the population. Taking an extreme case, if there is no variability, that is, if all the members of the population are exactly identical, a sample size of 1 is as good as a sample size of 100 or any other number. If we are talking about vice presidents of the company, it's very well understood. A person of at the level of vice president of a company, they will all be having the same qualifications, experience, but that is a probabilistic study. A second consideration is the convenience of the inference made. The larger the sample size, the higher is the confidence. In many situations, the confidence level is used as the basis to decide sample size. Try to understand this line. In many situations, the confidence level is used as the basis to decide sample size. Now comes your sampling distribution. Here we will be using different methods of studying the analysis of the population. Or in other words, we will repeatedly correct samples of the sample size from the population, compute the statistics, that means we will be finding mean, standard deviation, proportion, and then we will draw a histogram of the statistics. The distribution of that histogram tends to have is called a sample distribution of that statistics. Now, this terminology will change. And what I told you in that slide, the difference between sample and population. Now you will see. Sampling distribution of sample means from a normal population. Let X be the sample mean of the random size of n, drawn from a population having mean m and standard deviation s. Then the mean x bar will be equal to mu x bar is equal to mu, and the standard deviation will be sigma x bar is equal to sigma upon under root n. After selecting a sample, one would like to go for populations, regression analysis. Now the thing is that where we will be using these are the areas where we normally apply statistical tools. Any question what we have discussed today? आपको आज की क्लास के बारे में प्रोबेबिलिटी के बारे में कोई क्वेश्चन पूछना है? आपका कोई डाउट है? आप लोग मुझे सुन सकते हैं? आई एम ऑडिबल टू यू?
Yes,
Yes,
sir.
sir.
Here is no problem. You can
Yes, yes,
continue,
sir.
sir.
Okay. Now the thing is, what I mean to say is, we have reached probability distribution sampling stage. तो my suggestion is to all that आप लोग सारे formulas इसके समझ लें जो कि कंटेंट के अंदर अवेलेबल है हमारे, एंड इन अवर नेक्स्ट सेशन हम इसका प्रैक्टिकल एप्लीकेशन करेंगे, so that you should be aware of theory part of this sampling is almost completed. Now we will be moving to numerical part, and the later half regression analysis, correlation we have. Okay, is that clear now? Am I audible? There was some connectivity issue.
Yes, sir.
Okay, so can I conclude today's session? आप में से किसी को कोई सवाल पूछना है तो पूछ लीजिए.
Sir, we must read it and understand it. Now we don't have any question. If one suggestion, sir, if you share with us your PP and PowerPoint slide with us, because your slide is very your summarized. Yes, sir.
Definitely, I will do it. First of all, we should have a
Yes, sir.
discussion so that you are aware of what you are supposed to study. I normally discussing that thing which is important and which is applicative, which will help you to understand the concept of the things. Material is with you. I will be
Yes.
after the completion of the session. I will definitely share slides with you. That is my promise.
Okay, sir. Okay, sir.
Okay, so I'm concluding. Anyone else? So I'm concluding this session here.